Alright, welcome back. So last time we talked about encapsulation and data hiding, which are the same thing. So we used a private X modifier to make sure that you can't modify X, Y, or color or any attribute in this class without using a setter function, right? So without using a set function like set color, set Y, set X, we can't modify these values because they're private, right? Because private makes it so only functions inside this method can access these, right? No one outside this class can access these attributes because it's private. Okay. So before we get started, I want to talk about let's create a constructor, and we'll talk about how this is also mutable. So again, mutable as in M-U-T-A-B-L-E, right? Mutable. Okay. Which means that it's not thread safe, which again we'll talk about multi-threading in a future lesson, but it's not thread safe and it's just not preferred. So even if we don't use setters, okay, let's get rid of the setters. Okay, we instead use a constructor. It's a constructor object, just like we did in the last lesson, two previous lessons ago. And we create our point, so we do point p equals new point, and we pass in, let's say 5, 10, and green, right? And then we do p equals new point. Again, actually, I'm just going to copy and paste it faster. And let's make this blue, okay? So what's going to happen here is if we run a debug session on this, we're going to see that p's assignment, so you're assigning this value to p, right? You say p, point p, equals this. They're going to say p now equals this, right? So that's what you're doing. So you're reassigning what p is assigned to, right? So it's taking a long time to run. This is insane. Okay. First time it takes forever. Okay, so we have our p, now p equals 5, 10, and green, and we're on line 10, so let's step over to line 10, and now it's 5, 10, and blue instead of 5, 10, and green. So as you can see, it's still the same memory address, right? So, well, actually, you can't see that, but so this is going to store p's, or point p's attributes in a memory address. And let's just say it's memory address 1, right? It's memory address 1, okay? And we're going to say it's going to, instead of store, it's going to update. So it's going to, in other words, it's not going to create a new memory address to store this data in for point. It's going to use the same one. So this, in other words, it is mutable, right? It's not, immutable means it can't change. Mutable means it can change. So it is changing, right? So to make this immutable, if you want to make this immutable, we make the class final, okay? And we make every attribute final. So what that does is no one outside a constructor or static vector method, which and we'll talk about static vector methods in a future lesson, but no one outside of these two possible functions like constructor either a constructor or a static vector method. These are the only two functions that can access these attributes in this class because they're final. So in other words, if we create a setter again, let's just make this not final for a second just so we can create it. So if you create a setter for this, and then we make this final, now it's throwing an error because it says that cannot assign a value to a final variable x. In other words, like I just said, we can't modify these attributes because they're final outside of a constructor or a static factory method. It's very important. So in other words, we can't really modify it other than through this, right? In this case. And making this final means that the memory address is going to be new each time, right? So we create a final class point. It means every time you assign point, it's going to be somewhere different. The memory address it references is always going to be different. And then same thing for its attributes because they're also final. So final makes it immutable. So that's one way to make it immutable. It's probably the easiest way. So now, if we go back to this example, right, it's going to give you the same output, right? It's going to update P's assignment. So P's assignment can change, right? But where it's referencing is going to change. Sorry. Let me get that right. P's assignment can change, but where it references its value from is going to be different. It's going to be memory address 2. Now, so if we go ahead and go through a point, right? So we get 510 green, and we go through it again, and now we have 510 blue. Now, again, it's going to change the value of P's assignment, but it's going to reference a new memory address. Okay, so now it is immutable. Okay, but the problem I have with making a class final, okay, is you can't use inheritance. So what I mean by that is object-oriented programming has a very important concept called inheritance, and that concept is basically that a class can take attributes and common properties from another class. So for example, if we have a red point, right, and instead of creating like int x and int y, right, because a point has x and y, we can just say, okay, we already have a point class. We want to make this red, okay? So let's get rid of this color here, and we're gonna let our subclasses dictate what the color is, okay? So what we're going to do? So we're going to do this. We're going to create a point, right, with just x and y. Okay, let's not make this fun anymore, but actually let's make it fun first to show you that you can't do this. So we do extends point, okay, and it's going to say there's no default constructor available because whatever constructor you have in your superclass, whether it's default or has attributes, it has to be the same exact constructor or list of constructors in your subclass. So in this case, we have a constructor with 2 parameters here, right? So in our subclass, we also have to do the same thing. We have to have a constructor with 2 parameters, okay? And now we have an error saying that cannot inherit from final package 1.point because, again, it's final, which means that you can't do inheritance. So to do inheritance, you do extends, whatever class you want to extend. So you want to say that red point. So what you're saying here is that red point takes its values and attributes from point. So, well, really just attributes, I'm sorry. And functionality. Okay. So if we create a class here, it says public string get color, okay, and we say return black, okay, and we create, okay, so first off, let's slow down a little bit. Let's first talk about, again, we don't need x and y here because we get it from our superclass, so we don't have to do anything here, right? So let's redo this constructor. Let's just recreate it. So as you can see, you can pass in x and y here. It's going to update x and y here. So in other words, a red point, because it extends point, it's going to update x and y here. So in other words, it owns these values too. Like the attributes for point are also attributes for red point. So red point has, so in other words, red point has access, or I guess is made up of attributes that it defines itself and that it inherits. So in this case, it doesn't create anything itself. So red point is made up of x and y because it inherits them from points. So this is the key part about inheritance, that it can take whatever attributes that its superclass has. So this is called a superclass. This is called a subclass because it's extending the superclass. In other words, this is the child class and this is the parent class. So red point is the child class and point is the parent class. Okay? But we usually call it superclass and subclass. So subclass is the child class and parent class is a superclass. Okay? So you see something called super here. So we have a constructor, and what super does is it automatically takes whatever is done here. So it basically is the same thing as this.x equals x and this.y equals y. All right. Now, if we want to add a color here, we say private string color equals red, right? Now, if we go ahead and let's do this, okay? Look at that. We did point P, okay? It's not immutable anymore, by the way, because now this is not final anymore, right? If it was final, it would be immutable, but it's not because we have to be able to extend stuff. So if you want to have inheritance and immutability, there's other ways to make this class immutable, and we'll talk about that in a future course. But for now, let's not worry about immutability anymore. Let's worry about inheritance, okay? So we have a color red, okay? And so when you do point P equals new red point, so we're basically saying that we have a point, and we're actually, instead of creating a regular point, instead of creating just a point object, we're going to create a red point object, okay? And we could do this. No, we can't do the reverse side. We can't say a child class equals a parent class. We can't do red point equals points, right? But we can do the reverse. So we can say a point equals a red point because this is a child class. This is a subclass, right? This is superclass. Always can never be in the left. The superset can never be on the right-hand side. Superclass can only be on the left-hand side. We can just do something as simple as this. Just red point P equals new red point. We don't even have to specify point, but we can do this also because we're saying that at runtime. So at compile time, it's basically saying it's a point, but when you run this program, the Java compiler is going to say, okay, it's actually red point because we're assigning a new red point. So this is done at runtime, at compile time. So there's static analysis. So the code has static analysis and it has runtime analysis. And there's actually an important thing about inheritance called polymorphism. So what we're doing here, this is polymorphism. We're basically saying that we're going to, at runtime, we're going to turn this regular old point without any colors to a red point because red point has the color red. Now, don't forget we have this getColor function here, right? And we don't have a getColor here, okay? So we can actually do p.getColor because not only does a subclass or child class inherit attributes, inherits methods. So any method inside the subclass that is public can be accessed by the subclass, right? So if you make this, we're calling getColor, right? So actually, let's split this right so make it easier. So we call move right here, so you can see both, right? So if we go back to point here and we make this class private, now we can access it because it's private access. Remember, private means that only other functions in the same class can access. So if you have a private function in your signature, only other functions can access it. Only other functions can call this function. But if you make it public, then go ahead and access it because you can, because it's public. It can also be accessed if it's the default because it's in the same package. Oh, wait, sorry. Something called protected. I'm sorry, protected. I lost my train of thought here. Protected. And it still can't access it because, oh, I see. I'm sorry, I blanked out here. Let me take a step back. What I said was wrong. So if it's default, right, trying to access it in this test class, you can't because it's outside the package. So if you move this test class here, right, now it'll work. But if you also make it protected, we haven't talked about protected yet. Protected is the same thing as package protected. So the default means you don't specify anything, is package protected. So any class can access it in the same package. Okay? That's what that means, okay? Protected is the same thing, but any class in the same package or any subclass can access it. Even in a different package. So the only difference between protected and protected is that protected is actually more accessible than a default. So default is package private, which means that only the same classes in the same package can access it. But if you do protected, right, then subclasses outside the package can also access it. So for example, like if we move red point here, right? Okay. And we say we want to actually get the color, right? So let's try get. This is not good practice, but let's try getting the color. We just do get x. We can do get x. We can do get y. We can do get color because it is not package. It's not protected. It's package protected. So now if we change it to protected, right, or public, either one will work. Now it'll work. Oops, let me go back to red point. Yeah, see now it works because it's protected. So it means that any class outside the package that is a subclass, so again, this is subclass because it extends point, so it's a subclass, it can access its methods, right? So this is another key thing about inheritance is that protected allows subclasses to access it even though they're on the same package, okay? So let's go back here. So I'm kind of going off on a tangent because there's so much to teach and there's so much to know that it's just, it is important stuff. Okay, so but my main point here was, let's go back to my main point, which was if we run this, okay, we're actually going to get something that you're not going to expect, right? You're expecting to probably get red because you set red here as a color, right? Well, if you run this, let's just print it out. Let's not even debug this. Let's just run this. Let's print this value out. We're not going to get red. We're actually going to get black. And you're going to see why in a second, but let's just run it first. And the reason why is we're calling get color. And that returns black, right? And we're not overriding this function. So in other words, if we override this function, so if you do Command N or Control N and we say override methods, we can say we're going to override what? It's not there? Oh, maybe public. No, it doesn't make any sense. There we go. Hold on a second. This is weird. If I make this package protected again, or I make this protected. I can't spell today. Yeah, it still works. It just wasn't showing up. Let me do that one more time. This is not expected. Override. Oh, it is there. Oh, I see what happened. So what happened was it was package protected. So this is gone again. I deleted it and I forgot about it. I was wondering why it didn't show up as an option. So let's do that one more time. So see now it's throwing an error because it's not overriding anything because this is not accessible, right? It's package protected. It's in a different package. So let me just do it one more time. So if we make this protected or public, let's make it public, or it doesn't matter in this case because they're both going to be accessible, and we do override methods, it pops up as an option. So you can either do get X, get Y, or get color, right? Remember toString from before? This is again part of like how every class extends object and a toString implementation can be overridden. Remember that? So this is similar where we can override the value of get color. So we can do super to get color, and that won't actually override anything. That'll just take the value that's currently there. So we can say super get color, and it will just get whatever the superclass has. So the superclass has return of black, so it's going to return black still, right? But if we say, instead of superling a color, we say return color, right? Now, we return the correct color because it's a red point. We want to return red. And there we go. So actually, we don't even need this attribute. We can just say return red. And just to make it better, it should return nothing because there is no color set, right? So if basically what this means is that if you just use regular point, right? So this is just better coding practice. If you just have a regular point, okay, you shouldn't have a color because in this case we're saying that to have a color you have to be a subclass. You have to be specifically setting that color, and it has to be the same thing as the name. So if you do p like a color, we have nothing here, right? And if we do red point, now we have a color because we're overriding whatever the superclass has. The superclass returns empty because we have empty here, right? We're not returning anything. We're returning empty string, so it's not going to show anything. Versus if we return red, now we're returning the correct color, right? We're returning the color that actually makes up this point, which is red, okay? Let's go ahead and just create more of these classes. Let's create a blue point and a green point, okay? So we just have a couple different ones, okay? Just to show you that you can actually have multiple classes inherit the same class, right? So blue point, we said green point, right? So we have 3 different points, okay? And now we're just going to return green here, and we're going to return blue in the blue point. So we got 3 different subclasses. So they all extend point. So blue point extends point, green point extends point, and red point extends point. So they all extend point, and they all override get color. So they all return the color that they're supposed to return. So if we just do this, right, and we say we have a blue point, and then we have a green point, we say P2 and P3, and we just print out all 3 colors. Now let's go ahead and run this. Okay. So we have P equals new red point, P2 equals new blue point, and P3 equals new green point. So we have red, blue, and green. There we go. So now we're using inheritance to set the color for our points, right? So also the reason why we don't have a setter here is because in this case we are deciding that red point is always going to be red. So whatever your return is always going to be red. So you can also do this. You can also make a variable like we did before, right? Private string color equals red, and really you should make this final because it should never change, right? And you can just say return color. But either one works. I don't really think one is worse than the other. I just think that it's unnecessary to have this variable because you already know the color is always going to be red. You don't have to actually create a variable for that, right? In this certain case. But you can do that if you want. Either way, it's acceptable, I think. They're both kind of the right ways of doing it. Neither one is wrong. Now, the wrong way to do it is to have a setter or let someone pass in the value so then they can create like a red point. For example, let's do that. So let's create a constructor. Shoot. Right? And now, oops. Now we're passing in, I don't know, yellow, right? This is bad system design because now you're allowing the user to create a red point with the color yellow, right? This is not what you want. You want to be able to make sure that they can't modify the color, right? So you can't pass in constructor, you can't pass in as a setter, you can't just do like, to make this not final here, right? You can do setters here, right? So you can do like setter, right? And let's actually get rid of the constructor. Okay, so now we're saying that, okay, now we're saying, okay, let's say we do this, right? This is still bad. You're saying, okay, we're making it red. Oops. We're making it final, which is good, right? We're saying, okay, we're going to return the color, okay? Actually, then we can't use setters. Let's not make it final for this example. All right, so we're making it red. And then we're saying, if we run this, it's going to be red, blue, and green, right? Which is great. But if some programmer comes in and says, oh, you know what? I'm going to make this something else. I'm going to make it, ooh, what happened here? Oh, I see what happened. Let's make it purple, right? So this is called, I don't want to get into this already, but this is called casting. So you're saying that, this looks really weird, right? All you're saying is that it's originally a point, right? Again, at static time, it is a point. So it can't use the functions that red point has. So, for example, if you do p dot get x, right? It doesn't have this casting because you're getting the function from the superclass. But if you're trying to access a function in a subclass, and the left-hand side is a superclass, you're actually trying to access the subclasses methods with the superclass, right? You're saying p dot set color. Even though you're creating a red point, right? You can't actually access set color without using a cast, right? So it's saying cast may be removed by changing the type of p to red point. So in other words, if now it's a red point, okay, you don't have to actually do a cast because you already know it's going to be a red point from the start. You're not actually saying, okay, point p equals new, whatever, red, blue, or green. You're saying from the start, from the get-go, that it is a red point. Okay, this is very important too. So it's something called casting, right? So you're casting. Let's go back to our casting example. You're casting the superclass to allow it. You're casting it as a red point to allow it to access its subclasses method. This is actually a dirty trick. I would not recommend. If you see this in code, run. This is not recommended. Now it is legal, right? It actually does work, right? So if we actually run this, okay, if we run this, this is really slow today. Okay, we get purple, right? So we get a purple color for red point, which is not what we want. But if we go ahead and uncast it, right, it's still going to work. Okay, so if we do just the regular red point p equals new red point without having a superclass assignment on the left-hand side, and dynamically at runtime creating a red point. So statically it's a red point and dynamically it's a red point. So static again is the left-hand side, the dynamic is the right-hand side. So static means that when you're trying to access the class in the code, it's only going to be a red point. Or let's go back to the example. It's only going to be a point. And when you do it at the right-hand side dynamically, it means at runtime it's going to change to a red point. So the Java compiler is going to read this line and say, it's not a point anymore, it's a red point. So that's why you have to cast this if it's if you're using the subclasses method. Now if you just make it a red point, okay, you can just go ahead and run it again. It's still going to return purple because it is a valid argument, right? It's a string, passing a string here, right? Requires a string, okay? So this is not what you want. Again, so you don't want to use setters in this example because you don't want people to modify your color. You want to make sure that's only going to be red. So you make it final, right? Or you just return red, which is what I did before, right? This is actually, either way works. I'm going to go back to my example. So we have our red, blue, and green points, okay? So we did something called polymorphism. Okay, so this is a very important concept, which means that we're going from superclass static assignment. So you're assigning the type statically as a superclass type, and then at runtime, you're doing a subclass static assignment. So you're assigning the type to be a subclass at runtime. So when this runs, it's going to change to red point. That's pretty cool, right? So the Java compiler is able to realize that at runtime, it's actually a red point. So that basically wraps up this lesson. On the next lesson, we're going to talk about a different way to make this class immutable. Right? We want to make it immutable and still have inheritance. So we'll talk about that next lesson.